Hey everyone, welcome back to another video from my channel. In our previous video, we discussed about stem and leaf diagrams and how we can use them to find out the quartiles and other data values. Today, we will be learning about skewness. The shape or the skewness of a dataset can be described using diagrams, measures of location, and measures of spread. A distribution can be symmetrical, have a positive skew, or have a negative skew. Here in the first diagram, the distribution is said to be symmetrical if the shape looks something like this. Similarly, if the shape of the data looks something like this, then it's going to have a positive skew, which is to the left. And this one represents a negative skew, where the distribution is going to be slightly to the right. Data which are spread evenly are symmetrical. Data which are mostly at lower values have a positive skew, and data which are mostly at higher values have a negative skew. There are several ways of comparing skewness. Sometimes you will be told which to use, and sometimes you will have to choose one depending on the data you have available. You can also use the shape of the box plots to determine whether the data is skewed or not. Here, if the size between the differences of Q3 and Q2 as well as Q2 and Q1 are similar, so in this case, this is going to be symmetrical. However, if Q3 minus Q2, which is this distance, as you can see here, is greater than Q2 minus Q1, which is this distance, then this is going to be a positive skew. And finally, if Q3 minus Q2 is less than Q2 minus Q1, then this is going to be a negative skew, where Q3, Q2, and Q1 are the upper quartile, median, and the lower quartile respectively. Another test uses the measures of location. If mode is equals to median is equals to mean, then the distribution is going to be symmetrical. If the mode is less than the median and less than the mean, then this describes a distribution with a positive skew. And if the opposite happens, where mode is greater than the median, which is also greater than the mean, then this will be a distribution with a negative skew. You can also calculate 3 multiplied with mean minus median divided by standard deviation, which tells you how skewed the data are. If the value is negative, then it's going to be a negative skew. If the value is 0, then it's going to be symmetrical. And if this value is positive, then this is going to be a positive skew. A value of 0 implies that the mean is equals to median, so the distribution is symmetrical, as I've just said. Similarly, a positive value implies that the median is less than the mean, so the distribution is positively skewed. A negative value implies that median is greater than mean, and the distribution will be negatively skewed. The further from 0 the value is, the more likely the data will be skewed. Here we have an example question. The following stem and leaf diagram shows the scores obtained by a group of students in a test. Here we have the stem being the score 2, 3, 4, 5, 6, 7, and 8, and these are the leaves. Here we have a key where it says 6, 1, basically means 61, and we are given that the modal value is 68, the mean is 57.46, and the standard deviation is 15.7 for these data. So for number A, we have to find the 3 quartiles. So we can use the normal rules. Q1, which is the lower quartile, is going to be at n by 4. Here, we can add all of this together, and we get a value for n being 50 here, meaning that there are 50 data sets. So 50 divided by 4 gives us a value of 12.5. So since this is not a whole number, we have to round this up to 13. So the 13th term will be the lower quartile. Here we can see that this is 8, and 8 plus 7 is going to be 15. So this is the 15th term. This is the 14th term, and so the 13th term is going to be 46. Similarly for Q2, which is going to be n divided by 2 term, which is going to be 50 divided by 2, giving us 25. As you know, 25 is a whole number, so in actuality, the median is going to be the average of the 25th and the 26th term. So we add them and divide by 2. Here there are 15 terms here, and this is going to be 25. So this is the 25th term, and the 26th term is 61. So it is going to be 59 plus 61 divided by 2, and this gives us 60. Similarly, the upper quartile is going to be n divided by 4 multiplied with 3, and this gives us a value of 37.5. And since this is not a whole number, we have to round this up to 38. Now we have to find the 38th term. Here, this is going to be 3, and this is 8, so 11 from 50. So 50 minus 11 gives us 39, meaning that this is the 39th term, and this is going to be the 38th term. Therefore, the 38th term here, which is the upper quartile, is going to be 69. And these are our quartiles. For number B, we have to calculate the value of 3 mean minus median divided by standard deviation to calculate the skewness. So mean is 57.46, and the median here we have found is 60. So we can just simply say that the data is going to be negatively skewed because this will give us a negative value, and dividing with 15.7 gives us a value of approximately minus 0.480. Now this means that the data is negatively skewed. So we can write this down, that the data is negatively skewed, for a suitable comment about the skewness. Now for number C, we have to use two more further methods to show that data are negatively skewed. So first of all, we can calculate the difference between the quartiles. For example, we can calculate Q3 minus Q2, and then calculate Q2 minus Q1. Here, Q3 minus Q2 will be 9 using this, and Q2 minus Q1 will be 14 using our values from here. For example, Q3 minus Q2 will be 69 minus 60, and Q2 minus Q1 will be 60 minus 46 to get these answers. And as you can see, 9 is less than 40, so Q3 minus Q2 will be less than Q2 minus Q1, and this basically means that the data is going to be negatively skewed, as we have discussed here. Now using another method, we can say that mean, median, and the mode can be compared because they are given. Here the mode is 68, the median is found to be 60, and the mean is 57.46. So we can see that mean is less than median, and median is also less than mode. So this will be the signs, and these two informations will indicate that the data are negatively skewed. So thank you all for watching. Please make sure to leave a like, comment, share, and subscribe if you enjoyed my content. Peace out.